How's it, Oaks? So this is the video of me modeling a little coffee dispenser that I thought would be very useful in the mornings, just to press a button and a machine will dispense your coffee, sugar and creamer or whatever into your cup, and then you just pour your boiling water in it afterwards. Instead of having to open each container and use a teaspoon, ain't nobody got time for that. So my idea here was to get some kind of a cup, a bucket, roughly the same volume as a teaspoon contents. Oh, that's like 5 milliliters or something. And it basically slides in and out of a cradle, and I'm now modeling the cradle, as you can see there, the purple part. And this is obviously very early stages. This whole machine kind of blooms into fruition quite nicely. But my friend and I, my friend Clinton Moss, he's also very interested in this kind of stuff, 3D design, Arduino, laser cutting, 3D printing. We both love it very much, and so we thought, why not mix this in as a hobby to sort of spice up the mundane. So we thought, we both love our coffee, and so, why not make a little machine that automatically dispenses it if you press in your setting. And we'll get to the Arduino functionality later. But right now, as you can see, I'm just getting the tolerances of this little bucket and cradle, or should I say mini cup and cradle. Tolerances, we found out that, like 200, like 0.2 millimeters is a good tolerance. Maybe even 0.3. If you're printing with 0.4 millimeter nozzle at 0.2 millimeter layer height. So now what I'm doing here is importing a little rack and pinion model that works with a servo, a 9-gram servo, and at the bottom left there you saw the link, and the guy's name is Geek Makes. So thanks very much. So what I'm basically doing is just using it as a template, because later on I'm actually going to remodel everything, and the gear is going to be bigger. I'm remaking that gear with more teeth, and I'll essentially just be left also with a section 5 teeth of the rack. But right now I'm remodeling things so that I can use it in my project, because you can't really use an STL file and manipulate it unless you convert it to a mesh, which I tried, but then even then it's it just slows down the resources and you can't really do as much. So I'm modeling the profile of the teeth here of the rack, and what I'll do is then extrude this profile through this right there, and now I've got my own little rack, and so it just makes it so much easier to cut up and manipulate and whatever I need to do with it. And now I'm modeling the profile of the channel where the rack goes through. Just want to make sure that the channel is completely open and secure and so forth. Now I am modeling the profile of, I guess you would call this the the housing, the gear housing, which is attached to the the rack cradle, right, and channel. So now I'm busy doing that and literally recreating that whole effort. But once again, thanks to Geek Makes. You can download that STL from Thingiverse, and it works with the 9-gram servo, your typical 9-gram servo. So what we tried later on is, see, that's how the movement happens, as you can see there. The red part is the little cup and rack assembly. Yeah, well, we tried a 9-gram servo, but just didn't have enough torque. And so we're using a little bit of a bigger one that also uses 5 volts. It has a lot more torque. I mean, the 9-gram servo is rated at like 1 kilogram. And our, so we thought, the bigger one, which is 4 kilograms, might work better. So now I'm busy making the hopper. Well, I've made the hopper now, the little sort of sliding cradle mechanism of the hopper so that it can slide in and out of the assembly that I've made there. And just like that, that's how it slides in and out. Yeah, so that's pretty cool. And now I'm just gonna chop it up so that I can make a hole and see things clearer. And the powder, sugar or whatever, is gonna go through that hole, through the hopper, and into the red little bucket thing. And the red bucket will slide to the left and into the opening at the bottom there, from the purple, there we go, from the purple hole. And that's how that works. I'm just making little tabs so that the hopper can have a nice little stopping, stop so that it doesn't go too far. So this is how it works, as you can see. So what I have here is modeling the update. Before, this little hopper situation used 1 servo per bucket hopper. And now what I'm doing here is just as you can see, I've extended the back part right there, and I'm extending the front so that the slider, or the bucket slider, which is attached to the rack, can move 1 length further. So basically a length is the length of the bucket, and it needs to move that length to close the hole, and it needs to move that another length for the other twin hopper to So what I'm doing here now, as you can see, is inverting the rack, because I want to get the servo out of the way, because before it was sort of in between the 2 hoppers. As you can see now, I'm multiplying the hoppers, and so my servo needs to be below this whole situation so that the hoppers can kind of be together, So that's the idea. And also I'm using a bigger servo with a bit more torque, because our tests revealed that the small little 9-gram servo doesn't have enough power and torque to overcome the friction of the sugar and the components and everything together. And I have decreased the tolerances so that they don't rub against each other too much. So yeah, that was basically me mirroring the whole assembly and getting it doubled. And now what I'm doing is modeling the bigger servo, because I have the servo here, and I just had to use the calipers to make some adjustments and measurements so that I can get them translated into the program. And as you can see here, I'm using 123D Design by Autodesk. They discontinued this program, unfortunately, but it's a really good program. It's not parametric, but it's very powerful. You can do pretty much like anything with it, almost. So this is now where I am increasing the circumference of the gear to 1/3, and I've done some calculations there, as you can see. So here I'm now increasing the circumference to 1/3, not the diameter, because the circumference implies the travel of the gear. So as you can see, it's a little bit bigger than the original blue gear that you can see there. Now I'm just copying a tooth, and what I've done here is a mistake because I took the distance between the width of the tooth itself, but I should have taken the distance between the tooth spacings. And you'll see a little bit later on that my tooth spacings on this gear is a little bit too close, because the spacings on the rack and on the original gear is a little bit bigger than the width of the tooth. So now I'm taking this assembly and moving it to the rack over here, and this is where I now notice that it's not quite lining up, and I'm very confused and frustrated. So I bring out the original gear and just to check out the spacing, because I was like, what, how can this be? And so there we go, I'm bringing in the original gear here, aligning it up and orienting it, and there we go, voila. As you can see, the tooth spacing is a little bit wider or bigger than my one. So that means the number of teeth on mine is roughly 1 too little. So if I had to just delete all of them, which is what I just did there, and now what I'm doing is modeling the tooth again, or just getting a profile of the tooth so that I can extrude it right there. And once I've extruded it, I can now multiply them and get the right, there we go. So there's the right tooth spacing. Literally just took 1 extra tooth, and now that's looking good. So now what I'm doing is modeling with the calipers on the actual servo the exact location and size of the screw holes on the servo itself. So yeah, once I've done that, obviously what I'll do is extrude them like that, and the next step is to mount the servo onto the frame. And so I'm like wondering, should I do it there? No, it's not really appropriate, because the screws need to sort of go in the from the front to the back. So I'm now orienting this servo to see if it's going to be better here and there to get more space. And so I thought, this is the best orientation. It's very symmetrical. Cool. So now, as you can see, I'm going to get a basic shape for the mount, the servo mount, and it needs to go behind the tab, the servo tab, because that's where the screws bite into and hold the servo fuss. Okay, and now I'm drilling little pilot holes into the mount. They're going to be smaller than the actual screws because I'm going to be using self-tapping screws. And just a bit of extra support on the mount, just to give it more body and what. And that's pretty much that. So next up, I'm basically gonna model or just duplicate what I have here, because I'd like 4 hoppers, and for your coffee, sugar, creamer, and let's say cocoa powder or hot chocolate or whatever. So I'm taking this, the servos are going to have to be out of the way of the center, because later on I'm going to model, well, this is this video now, I'm modeling the chute, and the chute kind of has to have clearance. So I actually went through like 2 prior designs of the chute, and they didn't kind of work out. So this is the one that I thought, it might work, So I'm busy using a really cool tool that takes a profile, or 2 profiles, or even 3 or 4, has many profiles, and then you link them together, and it connects, and it's a pretty cool thing that this program can do. So now to give clearance to the gears, I've cut a hole into this thing and I've shelled it, and now it's hollow. And more or less that's how the chute looks, so that all the powders can kind of congregate in the middle where you place your mug under. Now I need the chute to be able to fit into the rest of the structure, so I'm making sort of dovetail slidable tab thingies. Yeah, and so this was also a very important thing, and quite a, I mean, very fun thing to model as well, you know. One thing about it, I know I've learnt about modeling is, you know, 3D modeling and designing, is that sometimes it's daunting. You don't know where to start and how to start, but you just start, you just do it, you know, and then it kind of works out. It's very cool. This is basically it. I've made like a little very, like a center point where I can mirror things in 2 axes. So I've basically cut up the chute and used just the 1 quarter and, you know, mirrored it accordingly to get the 4 quarters, so that I don't have to remodel every little dovetail tab. And so that's it. That's how that one looks. Thank you for joining me, and hopefully I'll see you again, and hopefully we'll get this thing sorted.